I'd now like to talk about optimizing our model. Um, we've done some good things already in regression as it relates to imputing some variables, but another problem that can come up is that our variables may have a significant amount of skew associated with them. If I go over to the data partition and click on variables, the ellipsis that's there, and look at these variables for gift count or just gift, it will pull up a list of histograms. Any of the ones that have a significant tail on them are a candidate for, or those are skewed, so we might provide or perform a transformation on that variable so that it is more symmetric and more bell curved. And one of the ones that we can use is the log function. And the log function, really what it does is it'll compress and bring down really high values. So the low values stay kind of the same, and the big values end up getting all squished down. And anyway, that's a good thing, and can help our model perform better. So the good news is our model will likely perform better when we do that. But the bad news is it's harder to explain then what it means, because as it is, if I were to look at something like gift amount average all months, if I said that the average over the last 36 months that someone's given is $1.50, and that and if and anyway, if we put that into the formula for a regression, we can talk about, very straightforward what giving something means. From $1.50 to $405, that's our range of donations and stuff. But if we transform the scale of this by taking the log of it, well, now we say that the input value is the logged gift amount value, and so that number just doesn't mean quite as much to us if we're talking to a business person about it. Now, based on the histograms that we were just looking at, the book argues that everything that other than the time gift variables are skewed, and so if we select just these ones, we can perform a simple change to these and click OK. And if I just go ahead and run this again, it should go through all of the steps all the way to getting me to stepwise, and I will get a better outcome than I did before. This may not always be the case, but you can verify this by looking at your misclassification rate or your average squared error. If I click on the transform node and look at its results, I can see that the gift variables that I used before have now been used to create new variables, and when these variables are used as part of a stepwise function, it will determine whether or not these variables perform better in predicting an outcome than these ones. And I have just looked at the results for the regression, the stepwise regression that was performed based on including the logged variables, and I see that it looks like this chi-squared value is getting higher than it was before, so I probably have an even better model. And these are the variables that it selected as being useful in predicting the outcome. So I guess in the near term, what we can say is that we've now included these two logged variables, and they matter more than maybe just a straight gift average all variable. Now, the logged version of that is actually more important in predicting things, and it's highly significant. Very, very important. And now maybe from a bigger perspective, we can also look at what we started with compared to what we have now, and we see that this imputation indicator is important, and these other variables that we created are also important. A couple of times while working on regression, we've made changes to interval variables. So for example, the first replacement we did was when there was a zero in the income of people. We changed that to missing because that was more appropriate. We've done imputation, which allows us in this particular case where we had a bunch of missing values on interval data to put the average of any column of variables and fill that in the missing spots. We haven't talked about class variables and one of the problems that they might introduce to performing regressions. With regressions, if you have a continuous variable, an interval variable, and it's creating the formula for that, then you usually only get one single variable where you plug in the value for your continuous variable. So the models kind of look like beta 0 plus beta 1 x1 plus beta 2 x2, where x1 x2 etc. is the actual value of your observation for a given row. So it could be x1 could be age, but when it comes to categorical variables, if there are, let's just say you have a color and it's green, yellow, brown, it will make different, what it does in regression is it will create different columns for each color in essence. And if there's only a couple of values, that's not a big deal. But if you have lots of columns or lots of values, let's just say you have 60 some values for a particular categorical variable, that means that you could be adding like 59, 60 columns with different variables in them to your model, and that is bad. It makes it harder for the math to find the true signal compared to the noise. So bottom line is, if you have a variable, a categorical variable, in our case dem cluster has many different values that it could have, you want to reduce the number of different options there are there if you think it really doesn't matter. If you think, like, for example, for demographic cluster, if 1 to 30 really kind of fits into one grouping and 31 to 50 fits into another, it's much better to have rename those to group 1 and group 2 than to have 50 different options. And so let's look at putting in another replacement node to fix a problem related to having too many categorical options. So I bring this down, and I've already selected none here for interval variables because we don't want to mess with that in this pass, but we do want to mess with the class variables. So let's pull that open and look what we have available. And in looking at this, I see my class variables and the different values that are associated with it. So with dem cluster, one of my variables, there's a ton of different values that takes on. And I think ideally it would be nice to just enter in a number there to kind of recode those. So in the real world, you'd probably recode it to something else that makes sense, so you'd reduce the number of values that it has. So maybe you thought really there's only group 1, 2, 3 or ABC, something like that. You could just kind of pick those out and reassign them to ABC, and then every single level is accounted for. Gender is probably not so bad. Female, male, and unknown. Well, I guess we have two versions of unknown, which is a little weird. For purposes of this demonstration, we're going to pick on this variable right here, status cat96nk. Now, I don't recall off the top of my head what this means. I do know that it keeps coming up as a significant variable in our model. If you recall that when we do the odds ratio estimates for this particular variable, it'll say A versus S and F versus S and N versus S and E versus S. So these values represent an increase or a decrease, and just in the outcome variable. But it also adds on, in essence, 1, 2, 3, 4, 5, 6 or so different variables, so one less than the total number of options that are there. And so that's kind of bad to have too many things, more particularly so for this demographic cluster variable. But it's just to demonstrate how you would fix that problem. I could have A continue to be A. I could have S now be A. I could have f be n, n be n, and this one be L and L, and really I'm done. Once I run this, it will replace the values and create a whole bunch of new ones. If I look at the results of this replacement node, it tells me up at the top that the number of replacements that were made, 1625 in the training data set and 1627 in the other. And then if I were to go view model replace levels, it pops up in this little box here, which just kind of, maybe I forget after the fact what I did, so I can see that what happened, that an original value of A became A, original value of S became A, etc. I reran the regression, the stepwise regression, with my new transformed categorical variable for status cat 96k nk in the model, and when it got through selecting its significant variables, these ones were the ones that were selected, and it opted to include this replaced value column that we just created as an important column in there over perhaps the original one. And if I go down and kind of see how that works in terms of prediction, now it's just looking at 3 different levels of these variables, well, yeah, because there's only 3 different variables now. There's A, L, and N. N is created at as the default case, and the other 2 are the alternatives. And computationally, this is better for getting a signal out of the noise that is there. The math works better. Now, of course, this isn't something you do arbitrarily. You should collapse levels if the levels are telling you the same thing. But if they're very different, then it doesn't make sense to collapse them. So use this with caution, and also look at what happens to the outcomes. Is this improving the the predictive capability of your model? Is it affecting the average squared error and the misclassification rate? Are those things going down by using this approach? If you've segmented things appropriately, hopefully the answer will be yes.